Today we're going to cover section 3.4, which is about periodic functions. So we're going to identify periodic functions and take a look at their periods. We're also going to look at cofunction, odd and even identities, and kind of relook at how to evaluate trigonometric functions. So anytime we have a curve described by the rotation of a point, we have what's called a periodic curve called a cycloid. So if you think of like a tire and you have a point on that tire, it keeps going around in a cycle. So we have that a cycloid type of a motion. So it keeps repeating. The horizontal distance before it repeats, so looking at the x value, so this horizontal distance is called its period. And each time it repeats is called one cycle. So a periodic function is defined for some constant c where you have f of x plus c is the same as f of x. So basically the c doesn't do anything because it repeats itself, okay? And then the smallest such positive value of c is called the period of that function. So let's take a look at this. This is a piece function. We want to go ahead and give the graph, period, domain, and range of the function. And then we're going to try to express this piece function, but we want to express it in a simpler form, or a cyclic function, a periodic function. So first, let's take a look at the graph. If we were to graph all of those pieces. For a domain, it looks like we are allowed to have all x values because even though we have a gap here, that gap is made up right here. So x's were pretty good. However, when it comes to the range, there's only two types of y values you can have. You can either have y equals 0 or y equals 1. So our range is a little bit more limited. So our period is 4 because if you notice, if you were to start at the origin, here's one cycle before your cycle starts over. So from here to here is horizontal distance of 4. So you have a period of 4. So with this information, we can start thinking about how to simplify this. So if we let n be the period number, and when we say the period number, like what period you're on. Like if n is 1, then you're talking about just this first period. If n is 2, you're talking about the period that starts after that. 3 would start after that. 4 would start after that. So let's go ahead and give the graph, period, domain, and range. And so now we're going to express it in a simpler form. So if we calculated the different parts of our period from the origin, from the beginning, right, that was 0. And it was 0 when x was between 4 and minus 4 and 4 and minus 1. However, after 4 and minus 1, that's when it jumped up to 1 until you got to 4n, which is once you got to 4n, that means your cycle is over and you start over again. You go back to 0. Let's do another example. So here's another step function. So this is what our graph looks like of that step function. So it looks like we have a period of 2. So our cycle repeats every 2 times, or every x equals 2. So our domain is all real numbers. However, our range can only be 2 and 3. It jumps back and forth between 2 and 3. So if we want to try to figure out a simpler function for this, what we'll do is we want to start from the y-axis. That's always the easiest part. So we let n be the number of periods. So that means that since the period is 2, after one period, we have 2n equals 2. So this is after one period, 2n equals 2. So then we go, well, what's the first time we make a change? Well, at 1. Okay, so if we change at 1, then this number here needs to become 1. So that means we need to subtract 1 from both sides. That's how we got 2n minus 1 equals 1. Our next change happens at 2, which means that we need to subtract 2 from both sides. So that's how we get 2n minus 2, and then 2 minus 2 is 0, and that's how we got the 0 here. So that's how we get these pieces of our function, okay? So now we can look at our function. So we're at 3 when we're at 2n minus 2 and 2n minus 1. And then after 2n minus 1, you go down here all the way until 2n. So here's another one. Here's a step function. So when we graph this, this is a little bit more complicated. It looks like our period goes all the way until 6. So we have a period of 6. So our domain is all real numbers, and our range can either be 0, 1, or 2. So now we figure out what are, how do we simplify this function? So one period is 6n equals 6, right? Because we let n be the number of periods, and so it has to be 6. So 6n equals 6. So our first change happens, we have a change at 3, right? So we subtracted 3 from both sides. We have a change at 1. So we need this number to be 1. So we have to subtract 5 from both sides. And then we also have a change at 6. So we need this to be 6. So we have to subtract 6 from both sides. So that's how we get our changes. Okay. So again, to get from here to here. All right, so now we're going to take a look at cofunctions, okay? So acute angles of a right triangle are complementary. So that means that they have to add up to 90, right? So in a right triangle, you always have one angle that's always 90. That's usually your C. It's across from the hypotenuse. But those other two angles, angle A and angle B, they also have to be add up to 90, or pi over 2. So that means that angle B has to be 90 minus whatever angle A is, or pi over 2 minus angle A. So using that thought, you can prove what we call the cofunction relationship. So here are our cofunction identities. So we say that sine of pi over 2 minus theta is equal to cosine theta. Cosine of that angle. And so likewise on cosine, you can do something for secant, cosecant, tangent, and cotangent. So notice how these all match up. We also have what are called the period identities, which says that sine of theta plus some multiple of 2 pi, that's what the K stands for, some multiple of 2 pi, is the same as just saying sine of theta. But remember, because if you're taking sine of an angle, if you add 360, you're technically at the same angle. Adding 360 and adding 2 pi is the same thing. All right, so let's list the special angles and give the cosine for each of them. So, and we want to look at all the quadrants. So start with quadrant 1. So we start at 0. So cosine of 0 is 1. And then pi over 6. So these are all the ones that you should already have memorized. However, when you go into quadrant 2, you have to remember your x values need to be negative. And that means that all of your cosines will be negative. When you're in quadrant 3, again, quadrant 3 and your x values should be negative, so all your cosines will be negative. And then when you get into quadrant 4, your x values are positive, so that means cosines will be positive. Okay, we also have something called the odd and even identities, which just says that if you have sine of negative theta, the only thing that changes is that your y becomes negative. And if your y becomes negative, you can pull that negative out, which means that negative sine of theta is equal to negative to the negative answer. So therefore, anytime you have sine negative of theta, just do sine of theta and then make it negative, and that's the same. You get the same answer. So cosine is a little different. Cosine is, if you have a cosine of negative theta, you just do cosine theta. You basically drop the negative. So those are the two odd even identities. So just to review, you should know these exact values. If you do not know those, then make sure that you relearn them. Use flashcards if you need to, but you are going to be expected to have those memorized. And that's all. Go ahead and try some problems.